Okay, so this is going to be quite a short video actually. This one is going to be talking about the properties of polymers. Now really I'm only focusing on this from the bonding unit perspective, so this is going to be quite limited compared to what we might get later when we start to talk about some of the triple science content. Okay, the real thing that I want to look at here is boiling point and melting point. Now remember, a polymer is a long chain molecule, or a large molecule, made of lots of small molecules called monomers. Remember, mono means one, poly means many. Okay. Now we've obviously looked at addition polymers in the previous videos, but really that's all I want to talk about here is just the boiling points of polymers. Okay, or I guess maybe the melting points as well, whichever way you want to phrase it. Okay, so generally polymers are solid at room temperature and pressure. If you think about nylon, if you think about polyethylene, if you think about any of these quite common, polychloroethylene, PVC for example, like pipes and drain pipes, that's a really good example. They're all solid at room temperature. Now we might start to ask ourselves the question as to why, because these aren't giant covalent structures, so they don't have those massive structures that give them that really high melting point, but they still have quite a high melting point. Why is that? So let's have a look. Now in order to do this, I'm going to try and just draw out two very general polymers. Okay, now I'm not actually going to put anything on them, and I want to stress here that this is just a representation. Okay, I'm not trying to do anything too detailed here. This is just a rough idea. So here's my two polymer chains. Now in between my polymer chains they're very weak, but there are lots and lots and lots of forces, and we might be able to guess what these forces are already. But there are lots of these weak intermolecular forces between the chains. Now although they are weak, and it's crucial, they are weak forces, okay, they're not particularly strong, these intermolecular forces, but there's lots of them. Okay, and because there's lots of these weak intermolecular forces, that takes quite a lot of energy to overcome, and that means that we're going to end up with a relatively high melting point, which is what's making them solid at room temperature. Okay, so just to sum that up, if you were asked, for example, why is polyethylene solid at RTP, room temperature pressure, it is because there are lots of intermolecular forces between the polymer chains and this takes a lot of energy to overcome. Okay. Now another thing might maybe be to mention that it's quite a, you tell them that it's a long, polymers are long chains. Okay, that might be worth adding in, but really we need to focus on this, the fact that there's lots of intermolecular forces between the polymer chains, and that takes a lot of energy to overcome. In other words, I need to give it lots of heat. It needs to be hot in order for it to melt it. Gives it a high melting point. Okay? Right, well that's it for this video, a nice short one. Okay, the next one's going to be looking at giant covalent structures and their properties.